Everything ends. Every star in the sky, every galaxy in the universe, and even the universe itself as we know it today is temporary. Right now, the cosmos is full of life and activity. Stars are being born, galaxies are colliding, and new worlds are forming across the darkness. But the universe is slowly changing. Stars will eventually run out of fuel, galaxies will drift apart, the energy that drives cosmic events will become more spread out over unimaginable timescales. According to our current understanding, the universe may not end with a sudden explosion. It may slowly fade into darkness. A future where the last stars disappear, black holes vanish, and almost nothing remains. This is the story of how everything ends. The universe began around 13.8 billion years ago with the Big Bang. At first, it was an extremely hot, dense state filled with energy and rapidly expanding space. Over billions of years, matter cooled and gathered together, eventually forming the first stars and galaxies. But while the universe is still creating new things, it is also slowly running out of the conditions needed for complexity. One of the biggest ideas behind the universe's eventual fate is entropy. Entropy is often described as disorder, but more accurately, it represents how energy becomes spread out and less available to do useful work. Every star that burns, every chemical reaction that happens, every process in the universe increases entropy. Over time, energy becomes more evenly distributed. The universe is not running out of energy exactly. Energy is conserved. The problem is that the energy becomes less useful. A hot star shining in the darkness creates differences in temperature, allowing processes to happen. But when everything reaches the same temperature, there are no gradients left to power change, and slowly that future is approaching. Stars are the engines of the universe. They take lighter elements like hydrogen and fuse them into heavier elements, releasing enormous amounts of energy. But stars cannot burn forever. Eventually, the supply of usable fuel decreases. The universe is currently in what scientists call the stelliferous era, the age where stars exist. This era is expected to last for an incredibly long time. The smallest red dwarf stars are the most efficient stars in the universe. Unlike massive stars that burn through fuel quickly, red dwarfs can continue producing energy for trillions of years. Some estimates suggest that the final normal stars may disappear around 100 trillion years from now. To compare that, the universe is only about 13.8 billion years old. 1 million years is already difficult for humans to imagine. 1 trillion years is a scale almost beyond comprehension. Eventually, the longest-lived stars will fade. The universe will enter a completely different era. After the final stars die, the universe will not instantly become empty. The remains of old stars will continue drifting through space. White dwarfs, the leftover cores of stars like our Sun, will remain. Neutron stars, some of the densest objects in existence, will also survive. Black holes will remain as well. The universe will become dominated by objects that are no longer creating new energy, just remnants. The future where there are no more glowing stars being born, no more stellar nurseries, no more galaxies filled with brilliant points of light. The universe will slowly transition from a place of creation into a place of leftovers. There may even be objects called black dwarfs. These are theoretical. They would be white dwarfs that have cooled down so much that they no longer emit significant light. However, the universe is nowhere near old enough for black dwarfs to exist yet. Their formation would require timescales far beyond the current age of the universe. Eventually, black holes may become the most dominant objects left. For an unimaginably long period, black holes could represent some of the last major structures in the universe. The black hole is not just a powerful object, it is a region where gravity has become so extreme that space itself is distorted. The largest known supermassive black holes contain millions or even billions of times the mass of our Sun. But even these cosmic giants are not eternal. For a long time, it seemed possible that black holes might be the final survivors of the universe. However, a discovery changed that. Black holes may slowly disappear. In the 1970s, physicist Stephen Hawking proposed that black holes can slowly lose energy through a process now called Hawking radiation. Because of quantum effects near the event horizon, black holes may emit tiny amounts of radiation. The smaller the black hole becomes, the faster it loses mass. For normal-sized black holes, this process is incredibly slow, almost impossible to imagine. The largest black holes in the universe could take around 10 to the 100 years, or a Google years, to completely evaporate. That number is a 1 followed by 100 zeros. The universe today is only around 13.8 billion years old. A Google years makes our current cosmic age look almost like nothing, but eventually, even the largest black holes may disappear. If the universe continues following this path, there may come a time when the final black hole evaporates. The last major object in existence vanishes. For a brief moment, the universe may experience the final release of energy from that black hole. A tiny, final burst of radiation. The last major event in cosmic history. After that, there may be nothing left capable of producing significant energy. No stars, no planets, no galaxies as we know them, just the remains of everything that ever existed. The most widely accepted prediction for the universe's ultimate fate is called heat death. Despite the name, it does not mean the universe becomes extremely hot. It actually means the opposite. The universe reaches a state where everything is extremely cold and energy is evenly distributed. There are no temperature differences, no engines, no stars, no processes capable of creating meaningful change. The universe continues expanding, becoming darker and emptier. Particles may drift through space for enormous periods of time. The cosmos becomes a place of almost complete silence. Not because nothing exists, but because almost nothing can happen anymore. Heat death is currently considered the leading possibility based on our observations of the universe's expansion, but scientists do not know the ultimate fate with absolute certainty. Other possibilities exist. One idea is the Big Crunch. In this scenario, expansion could eventually reverse and the universe could collapse back inward. However, current observations suggest the expansion of the universe is accelerating, making this less likely under our current models. Another possibility is the Big Rip. If dark energy behaved a certain extreme way, expansion could eventually become so powerful that galaxies, stars, planets, and even atoms could be torn apart. But again, this depends on unknown properties of dark energy. There is also vacuum decay. This is a theoretical possibility where the universe could transition into a lower energy state, changing the fundamental laws of physics. If it happened, it could potentially spread at the speed of light. However, there is currently no evidence that this will happen. These are fascinating possibilities, but they are not the expected outcome based on what we know today. Imagine a hypothetical observer billions upon billions of years into the future. There are no familiar stars, no galaxies shining in the distance, no warm planets orbiting suns. The universe is expanding into darkness. The temperature approaches an incredibly low level. The remaining particles are separated by enormous distances. Time continues passing, but almost nothing changes. The universe would not end with a dramatic explosion, no final battle, no final flash destroying everything. Instead, the ending would be quiet, a slow fading away. The universe would not end with a bang, but with a whimper. The strange thing about the end of the universe is that there may not actually be a final moment. There may be no last second, no final event. The universe may simply continue existing in an increasingly empty state. The concept of after the end becomes difficult because time itself continues. A universe that has reached maximum entropy may still exist. It would simply be a universe where almost nothing happens. A place where the greatest events in history, the birth of stars, the formation of galaxies, the existence of life, are memories from an unimaginably distant past. The universe began from a hot, dense beginning. From that simple state came everything we know: stars, planets, galaxies, life, consciousness, and eventually, according to our best understanding, all of it may slowly fade away. The stars will disappear, the galaxies will grow darker, the last black holes will evaporate, and the universe may settle into an endless ocean of darkness and silence. But there is something incredible about that story. The universe may be temporary, but for a brief moment it became capable of looking back at itself through us. Every thought, every discovery, every question about the cosmos is the universe itself trying to understand its own existence. And even if the universe has an ending, the fact that it happened at all is one of the most extraordinary things we know. Thank you for watching this video. I hope you enjoyed exploring the end of the universe. Let me know if you have any other theories about how the universe will end down in the comments. Make sure you hit the subscribe button, and if you have anything you would like to explore with me in a future video, I will do my best to make that happen. Stay tuned for the next video where we talk about the greatest mysteries in astronomy, and as always, stay curious.